Okay, so we talked about the components, right? Outline, picture, labels, arrows. Then we talked about the write-up, right? How do you do randomization? Where do you do randomization? Control or replication control. Couple things to add to that. Blinding. Okay, blinding is a possibility. Sometimes it works, sometimes it doesn't. Blinding. So what is blinding? Blinding is when you're giving something and the units don't know which treatment they're getting. So if you're giving something to an experimental a subject, they don't know which one you're getting. They don't know which treatment they're getting. Are they getting the placebo? Or are they getting the real thing? They don't know. That's blinding. Most of the time, it's done when you're giving something to somebody. You don't want them to know which one it is, right? But if your subjects are animals, it doesn't really matter. Doesn't really matter because animals can't really tell the difference between them. Okay. Or like the one we just did yesterday with the plots of land, right? Crops and plots of land. The plots of land don't know the difference. Okay. So you don't have to blind that. The blinding is not required there. But if you're dealing with people, blinding is something that you definitely want to do. Double blinding. Double blinding means I don't know which one I'm getting, and neither do you. So if I'm giving you a pill and you're testing this pill, I don't know which one I'm giving, and you don't know which one you're taking. So no one knows. Well, somebody does know, but not the people that are there. Okay, that's what double blind. Neither the subject nor the evaluator know which treatment a subject received, nor anybody who administers the treatments and or cares for the subjects. Basically, anybody who interacts directly with the experimental units. When you do an experiment, when you're part of a medical experiment especially, they know your name, they know all your stuff, but you're not referred to by a name, you're referred to by a number, right? Usually only one person has the name and the number together. And that person you never see that person because they worry about things like the next thing, placebo. Okay. So, placebo, a pharmaceutical company is testing a new headache medicine pill and wishes to test it in an experimental study against the control group. Is it possible for the experiment to be blinded or double blinded? Yeah. Right. Blinded, if I'm a person who volunteers for this, blinded to me would be I don't know which pill I'm getting. Am I getting the real pill or the dummy pill? Right? Double blind means the person who actually gives me the pill, they don't know either. They have no idea. Okay? That's usually what they are. Medical experiments are usually double blinded. There's usually one person who's in charge of the whole study that has a name and a number, right? So, and those people never come in contact with me who's in the study. Otherwise, there could be bias, right? Um, there could be issues with bias. Okay. The subjects can be blinded by giving a placebo, a dummy pill, which looks and feels the same and real as the real drug, but contains no active ingredient. So it's not going to do anything to you, right? It's like a water pill. If it's a capsule pill, it's filled with water, right? If it's an actual hard pill, it'll be like a sugar pill. It won't be anything that does anything to your system. That's a good question. A lot of people probably don't know. Or you're talking about like when you volunteer for the study, everyone thinks they're getting the pill, right? There's a lot of people who don't even know this, right? They've never taken a psychology class, a statistics class, a biology class. They've never done that. So they don't even know that's a possibility, right? So that's what leads to a couple down, the placebo effect. Placebo effect's a real thing. I'll give you an example. They did hair loss is one of the big things, especially for men, is a big issue, right? Men, as they get older, some tend to lose their hair. Um, So someone created, I forgot what it was, a pill or it was some sort of cream for the hair. I forgot what it was, but they wanted to test it. So they tested it. They gave half the people the real thing, the half the people the placebo, right? Well, afterwards, they how much hair did you grow, if any? People who took the placebo actually grew hair. They actually grew hair. And you're like, how in the world did that happen? You weren't given the actual drug, right? If you were given the actual drug, I could see how you grew hair, right? But people who weren't given actually grew hair. And they're like, not a lot. Not was it everyone? No, no, just a few people. Well, how did that happen? It's called the placebo effect. There is no explanation for it. There is no scientific explanation for it. The only real explanation is that the mind is a powerful thing. The mind is a powerful thing, and that's really the only explanation. So that is real, right? The placebo effect is a real thing and must be accounted for. Okay, so um, if I'm giving you a pill that is a new headache medicine, some people who are given the placebo, their headaches will go away. Why? I have no idea, but it's called the placebo effect. It can happen. Okay. Now, the majority of the people, nothing will happen because it's a dummy pill, right? But for some people, the placebo effect is real. Okay. So yeah, so everyone going in thinks, oh, I'm probably going to get the real thing, right? If I was doing a study, especially they always get college students to do these studies because college students are the ones in most need of money. And college students are young and healthy, so they don't have to worry about long-term side effects because college students for the most part are young and healthy. They always get those students to do these things, right? And because a lot of these experiments, a lot of these studies are done at universities, they're done in colleges. So how do I have to go that far? Just put a something on social media or put something out there that says I'm looking for students to sign up for my medical study, and then you go find out, you're like, and they'll actually pay you. They will pay you. Some of them good money. That's where they get most of their subjects, and yeah. So like I said, that placebo effect is a real thing. Okay. The evaluator should be blinded by not knowing which group received the real drug versus the placebo. Assignment of treatments should be administered by a third party. So if you're actually giving the drug, so what happens? You go up and they tell you to come at 1 o'clock. You come at 1 o'clock. They give you a pill. You go back. You go on and do whatever you were doing in your normal life. Go back to your normal life. When you get the pill, it looks like the real thing. You don't know if you're getting the placebo or you're getting the actual real thing. So and then you come back and then they ask you questions about how you feel or whatever they're testing. And they ask you questions. You usually do that for a month or two. Okay. Um, but you just got to be careful when you're doing those things. It's money that they're giving you, but a lot of these things are kind of the things they're testing are not necessarily safe, and you just don't want to be, you don't want any long-term effects from it. They'll explain everything, but you just that's why they get college students because it's easy to because you're like, what? You're paying me? Okay, I'll do it. You're young and you think, oh, nothing's gonna happen to me, right? They don't get people my age because people my age won't do it because we're like, why? Why? I don't need to do that. But so you just got to be careful with that. But that's who they get. That's who they get. Okay. So the placebo effect is a real thing. Is a real thing. Okay. So if I have a pill that cures headaches, the treatment group, their headaches will improve or their headaches will get better. Some of the placebo will too. Okay. That's what the placebo effect is. Okay. So what we talked about last time, actually 2 times ago, with designing experiments, right? Designing experiments, outline, write up. That's called a well-designed experiment. It's called a completely randomized. These are called completely randomized designs. Okay, that's what we've been doing. There are other types. One of them is called block design. It's still randomized, so it's still a randomized. It's just not completely randomized. Okay, it's called block design. That's one type. Why is block design different? How is block design different? Well, block design is an experiment. An experiment is conducted separately for different groups, different blocks of experimental units. We use blocks if you expect certain groups of unit subjects to systematically affect the response to the treatments. It is similar to stratified sampling. When we take a stratified sample, first thing we do is break into groups, right? I have 4 hats: 9th graders, 10th graders, 11th graders, 12th graders. Every 9th grader, I put their name in a hat. Every 10th grader, I put their name in a hat. 11th grade, 12th grade, and then I pick 10 from each, right? That's a stratified sample. This is kind of how we do that. Before we splinter off, so before I splinter off, I break them up, either by gender, by age, by ethnicity, by whatever. The reason you do that is because you think those 2 groups are going to react differently to um, my whatever I'm testing. They're going to react differently. So I don't want to compare men and women. I don't want to compare people over 40 with people under 40, right? For some reason, you think that you don't want them combined, right? If I'm testing, for example, if I'm testing a new health supplement, right? If I'm testing a new health supplement, give you a little pill. Take this pill. It'll make you healthy, make you healthier, right? So you take the supplement. I might want to, depending on how I'm doing my response, I might not want to mix male and female, right? I might not want to mix people who are older with people who are younger. I might not want to mix them for different reasons. For example, if it's a weightlifting thing, if it's a weightlifting supplement, I don't want to mix male and female because the average male can lift more than the average female. Does that mean every female can lift less? No. There are females who lift a lot, and there are males who don't lift that much, right? But the average male can lift more than the average female. So what I would do before I splintered off here is I would break them into 2 groups. Males, you're up here, females, you're up here. I'm only comparing male data with male data. I'm only comparing female data with female data. Okay? So before I even do any of this experiment, I'm breaking them apart. So essentially, I'm running the experiment twice. Once with only males, once with only females. Okay? Another reason to do it, if you're testing some sort of medical treatment, there are certain ethnicities, certain cultures that react differently to different diseases. Okay? So you're like, maybe everyone who is of that descent, I'm going to have in one group, everyone else in another group. Okay? For example, heart disease. Heart disease tends to run higher in people of color, right? Any minority, people of color, heart disease tends to run higher. It's just the way of the beast. It's just the way it is. So I would probably put everyone who considers themselves in that category up here, everyone else down here, and run the experiment twice, right? Let's see another one. Let's see, what's another one? Yeah, there's different things. Why is that? I don't know. I have no clue. I don't know why certain ethnic groups are more susceptible to certain diseases than others. I don't know, but sometimes they are. Okay. Sometimes women are more susceptible to certain diseases than men. Colon cancer. We just did a colon cancer one, right? Women tend not to get colon cancer. Men do. Now women can get colon cancer, but it's the majority of colon cancer cases are men, right? Just like breast cancer. Breast cancer, for the most part, almost only is women, but actually some men do get breast cancer. It is possible, but almost almost all cases are female cases. Okay, there are certain diseases that for some reason favor one over the other, one ethnicity over the other, one gender over the other. No clue why. Okay, no clue why. Okay, so for all of those reasons, we use blocking. Blocking. Okay, so it's still randomized. We still have RAs. When we draw the picture, we still have RAs. But before we do RAs, we split them up into two groups. I don't want male data mixing with female data. I want to analyze only males versus males, only females versus females. Okay? A block is a group of experimental units that are known before the experiment to be similar in one way that is expected to affect the response to the treatments. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. So you form blocks based on the most important and unavoidable source of variability, lurking variables, among the units. Yeah, again, if I'm testing something for colon cancer, I don't want one group to have more men and one group to have more women, because is the reason why they're not getting colon cancer because of the drug, or is it just because I have more men up here and more less women up here? So that's why I would block. I don't want that to be a lurking variable. Okay. Randomization will average out the effects of the remaining lurking variables and only allow an unbiased comparison of the treatments. Don't confuse this with the ones we've done before. Okay. And I'm going to explain. We're going to skip match pair for right now. We'll do match pair tomorrow. Let's go to this example right here. Next page, top of the next page. Okay, so example, people will use less water in showers if they can't control how hot the water gets. That's the question. If you can't control how hot the water gets, you're more likely to use less time, or more likely to be in the shower longer or less. We don't know. So we're going to test that. Okay, so the experimental setup. There are two types of showers. One of the showers allows water to get as hot as they like. So you have a nozzle, just like your shower at home. You can turn it as high as you want, as low as you want. You can turn it off when you want to. Okay. The other shower, there is no nozzle. Water is just coming out of it, and it's at 120 degrees, which is usually hot enough for most people. 120 degrees is it's not like scalding hot, but it's like it's on the warm side. It's some people like that. It's on the warmer side, so it's not like gonna burn your skin or anything. But 120 degrees is usually hot. Okay, some people like it that hot, some people don't. But that it's not like crazy hot. Okay. Um, so participants, you have 100 people who just exercised. 50 are men, 50 are women. So you're going to send them into these showers to test this, right? They don't know anything. All they know is they're going to go take a shower. That's it. That's all they know. Okay, so you're going to send them in the shower. But you have two separate shower systems, right? You got one where it's a regular shower, right? It's a regular shower. Turn it up, turn it down, turn it off, whatever you want. The other shower, there is no nozzle. You just walk in, the water's already running, and that's it, right? Maybe a button there. Maybe you push a button and the water comes out. Okay? So you want to test who takes longer in the showers. Is it the people who can control, or is it the people who can't control? That's what you're testing. Okay. So they want us to block for gender. Block for gender. That means I'm not going to mix the final data, males with females. I'm not going to mix their data. I'm only going to compare male data with male data and female data with female data. Mm-hmm. So does that mean you'll always have two outcomes? I'm going to have two things to analyze, yeah. Mm-hmm. I'm going to have two things, one for males and one for females. Okay, so I'm going to block for gender. So the picture is going to look similar, which is why I gave you a lot of room. The only difference is there's going to be two pictures, right? One of them is going to be 50 males. We'll do males first. Okay. How many groups am I going to have here? Two. So let me draw that picture. Here we go. Arrow there, and arrow there. Is there a control group here?
The one that allows you guys to say like. Oh wait, no.
You could do this a couple different ways. We could say the one that allows water as hot as they like. That's a normal shower, right? That's a normal shower. We could say that's a control group, or we can say there's two treatments. We're just comparing. Doesn't matter. Just note that in your thing. All right. So if you're going to put a control group, put it down here. If you're going to put two treatment groups, that's fine too. Okay. So say treatment one. Let's see here. We'll say that group is adjustable heat. We'll say adjustable heat because they can turn it up, turn it down. And we'll say the other group. Well, no, since we're saying the control would be adjustable heat. So if you're going to use a control, you would use adjustable heat down here. But if you're going to say that one's up there, then you're going to have two treatments. So the other one is 120 degrees. That's all it gives. Okay. How am I going to answer the question? How am I going to answer the question, who uses less water? Hmm? Compare the amount of water used. Okay. Compare amount of water used. So you have to have some way of saving the water to measure it, right? Another way to do it is just how long they're in the shower, right? Because if if both are the same pressure, right? And you can't change the pressure, then amount of time would also work too. Okay, either one's okay. If I was actually doing this experiment, I'd probably do more of a time because it's easier to measure, right? Because if you actually measure the water, it's tough to because you have to gather the water somewhere. Mm-hmm. Okay. Okay, so missing some things. We have to do women next. Random assignment, right? We need a random assignment. So where is random assignment going to happen for this guy? Yep. So which one's going to which shower? They're not going to have a choice. I'm going to send them. You go to shower one. You go to shower two. Okay. We're gonna get that. We're gonna get to that. Yeah, that's gonna be our next step. Our next step is how we randomly assign them. We need to do that. Before that though, we're missing something. Exactly. How many people are in each group? Does it have to be exactly 50-50? No. But get as close to 50-50 as you can. Since it's our experiment and we're designing it, we'll say 50-50. We'll say, actually not people, this one's men. And this is men. Okay. All right. The nice thing about this one is we have to do it again. So that's one picture. We have to do it again. The nice thing about this one is it's going to be the exact same thing just for women. Okay. So we're going to draw the same setup we did here. It's the same exact experiment. I'm not changing anything about the experiment. Why am I doing it twice? Because I don't want to mix male data with male data and female data with female data. I don't want to mix them. So however you conducted the experiment with males, you're going to do the same thing with females. You might even have them at the same time. All of this means is I'm not going to, whenever I get the data for men, I'm not going to compare it to women. I'm only going to compare the data for within gender. Okay.
Do we still have to write two separate systems?
If it's the same system, no. So we'll know that when we write our system. So we need to write our system for RA. We need to explain where RA took place and how the system, what the system looks like. Okay. So the first one, randomization. First thing is where randomization took place. Randomization was conducted to determine treatment. It was conducted to determine treatment. Treatment assigned, I should say. In other words, they didn't decide. It wasn't their decision. It was my decision. It was randomly decided which shower they went into. Okay? They both looked the same on the outside. The only difference is when they walked in. One shower you could control the temperature, one shower you couldn't. Okay? Okay, so the next thing is how I did that. How I decided who goes in the shower 1 and who goes in the shower 2. Again, this is where you have a lot of leeway. There's a lot of different answers, right? It just don't forget to remember to include everything. What was that? So the first one is I'm going to number each. So again, I don't want to make this specific to only females or males. So I'm just going to use broad terms. So I can say I use the same system twice. Number each subject 1 to 50. Okay. Mm-hmm.
If this system was considered for both
Mm-hmm.
governments, how would you know if it's like for both of them? Like how would you know systems for both governments? Like do you just
How do you know it's system? Well, let's do this first, and then I think I'm going to answer your question here in a little bit. Okay, so I numbered each person 1 to 50. Use calculator, number names in a hat, random number chart. However you want to do it, however you want to explain it, just don't leave any holes so that I can poke in there. So when I read it, I'm like, nope, you forgot that. Or how did you do this? If I have to ask those questions, that's you mean you missed something. Okay, so if you're going to use the calculator, because I can tell a lot of you guys like the calculator because it's the easiest, it's the one that takes the least amount of time, and it's the one that requires the least amount of writing. Okay, you guys aren't the only ones. Every year I have students that like to use the calculator. That's fine. Just don't forget things. Okay. Okay, so let's say we use the calculator. So use calculator to randomly pick first 25 subjects. And then we're going to say they're going to go to treatment 1. Or maybe let's write treatment 1. Next 25, go to treatment 2. Okay. And then I would explain one line says, same system's going to be used for both men and women. Same system used for males and females. Okay. So I just would repeat the system for the other gender. Okay. Replication. Numbers, right? Numbers. 50 males assigned to 2 groups, or 2 treatments, I should say. 50 females assigned to 2 treatments. Okay. I had 50 males, 2 treatments, 50 females, 2 treatments. Last one is control. So I don't have a control group in this one. I didn't use a control group, right? I decided not to use a control group, but I'm still going to compare things. I'm comparing the amount of water used. Okay. We'll compare amount of water used for each treatment. Can I use blinding or double blinding on this one? Is blinding or double blinding something I would want to use on this experiment? Exactly. There's no way to do it, right? Once they go in there, they're going to know, right? It's not giving them a pill. They're going to be in an environment where they'll know the difference, right? So there's no real way to, I mean, besides making the outside of the shower look the same, right? The outside of the showers look the same, so that when they walk in, they'll think, oh, it's just a shower. But when they get in there, there's no way to blind it so they can't know the difference. They will know the difference. It's either got a nozzle or it doesn't have a nozzle, right? So if there was a way to do blinding, we would do it. We would explain it here. You would explain. Experiment is double blinded, blah 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 blah, whatever, or blinded, whatever. That's where you would explain. Okay, and that's it. Or actually, you know what? I should probably put something about gender. Data will not be used to compare outside of gender. That means I'm not going to compare males with females or females with males. I'm only going to compare male amounts with female amount or with male amounts. Okay. All right. All right. We'll pick up where we left off tomorrow.